right, last and final set of notes here. We are going to be talking about Newton's law of cooling, which deals with the temperature of an object that has been heated. So we've got this kind of interesting equation that has a lot of different parts to it. We have multiple variables, and I need to make one quick addition here. This needs to be T sub 0, which is the initial temperature of the object after it's been heated. Okay? All right, so let's go ahead and look at the first example. A cake is removed from the oven. So the temperature of the cake when you remove it from the oven after it's been heated is 210 degrees Fahrenheit. And it's left in a room to cool that has a temperature of 70 degrees. So the constant temperature around the cake is 70 degrees. It says after 30 minutes, so that's the time that's been elapsed, the temperature is now 140 degrees. So the end temperature is 140. It says use Newton's law of cooling to model and to find a model to represent the temperature of the cake as it cools. So we're going to use this equation. And we're going to plug in the information that it's given us. So we know the temperature of the cake after it has cooled is 140. Its constant temperature around the cake is 70 degrees. When we pulled it out of the oven, it was 210. And we know that K, which is the negative constant, which we don't know, K, we're going to leave that as K. And we know that 30 minutes has elapsed. So that's going to be our equation. It says, what is the temperature of the cake after 40 minutes? So in order to be able to do that, we need to figure out what K is. So what I'm going to do is I'm going to work on simplifying this a little bit. So 140 equals 70 plus 210 minus 70, which is 140. And we have 30K. Okay, and then we're going to subtract and divide and use the natural log to solve that. So I'm going to have ln of 0.5 equals ln of E30K. And what's going to happen is those are going to cancel out, and I can divide by 30. And I'm going to get K, which is negative 0.0231. And a couple things that you need to know is that K is usually going to be a negative number when you're solving for that. All right, so what we know now is that we can have this equation of the temperature 70, 140, E negative 0.0231 T. So after 40 minutes, we can plug in 40. And we can use our calculator or Desmos to calculate the temperature. I'll plug all of that back in, and the temperature is going to be 125.57 degrees Fahrenheit. So what we're going to do is create the equation, solve for K, use K to plug back into the equation to find the number that we want. Lastly, it says, when will the cake be cooled to 90 degrees? When will the cake be cooled to 90 degrees? So remember, we have 70, 140, negative 0.0231 T. We're looking for when it will be 90. So we're going to subtract. We're going to divide. We're going to use the natural log of both sides. That's going to cancel out, and we're going to divide. And T will give me 84.239 minutes, or an hour and 24 minutes. All right. Newton's law of cooling.